All right, so this is Chapter 9, Section 1. It is called Mathematical Patterns. And I think it's just a good idea every now and again to write the word mathematical because we truncate it into math so often that I forget, is it an E, is it an A? What happens after math? Our learning objective is to identify mathematical patterns found in a sequence and define the nth term of a sequence. So we have a new topic. It's something that we've been doing for a while, but now we're going to put some words and definitions and vocab on top of it. All right, so a sequence is an ordered list of numbers. For example, 1, 2, 3, 5, 8, 13, etc. What we want to look for here is what's the pattern. So if you go, what's the difference between 1 and 2? That's 1. What's the difference between 2 and 3? It's 1. Difference between 3 and 5? It's 2. Someone let me do it too. The difference between 5 and 8 is 3. Difference between 8 and 13 is 5. So what you're doing is you're looking for patterns or some way to predict the next term. And then that brings us to our next word. It's term, and I put in parentheses of a sequence, so you know what we're talking about. So then it's a number in a sequence. So for example, the fourth term in the above sequence is 5. So we go 1, 2, 3, 4. So the fourth term is 5. So when I talk about term, I'm talking about the specific number inside the sequence. Now this is where we get awesome. The explicit formula is a formula to find the nth term. So any term in a sequence. So what I've done here is I've given you guys a sequence. 1, 4, 7, 10. What is the pattern for 1, 4, 7, 10? So what would our next number be? 13. And how did you guys tell them? So each time we're adding 3. So we need a formula that no matter where we are with the sequence, so if I said I wanted the 20th term, I could go and write down all 20 of them, but that would seem really hard. Wouldn't it be nice if I could put together a formula that I could just put the number 20 into it and find out what it be? So let me show you. So to find the nth term, and if you guys look, this is a little, it's a subscript n. So A is the term. Subscript n means whatever term in my sequence, right now it's undetermined. It's kind of like the variable, it's like x. And here is the formula. If I start with the 1 and I say add 3, parenthesis n minus 1, we're going to put, I'm going to show you how to make these formulas in the next section, but right now we're just looking at what an explicit formula entails. So for example, if I wanted to find the 20th, so you can test it to see if I was looking for the second term, A2, I've just put the number 2 in for n. And we can say 2 minus 1 is 1, 1 times 3 is 3, and 3 plus 1 is 4. Is the second term in my sequence 4? Yes. So we can verify that the formula works. Okay. Here is, explicit formula is usually what we do in math. We have little equations. We plug in the number we want. So the next section, the next vocab word is going to be completely new, completely foreign. We're going to talk recursive formula. And I like recursive formula because in a way it has a more simplistic approach than an explicit formula. It relates each term to the one before it. So if I want, all I want to do is find the pattern. So with a recursive formula, you have to identify the first term. So let me give you, actually let me give you the generic form of it. And then I'll show you how to fill it in. All right, so for a recursive formula, you have to identify the first term. So in our sequence up here, 1, 4, 7, and 10, what is the first term? Promise you it's equal to 1. So because recursive formula relates each term to the one before it, if I don't have a starting term, I have no way to keep going. So we always have to identify what our starting term is. So in this case, it's A1 is equal to the number 1. And then, which is right here, and then we have to say the next term, or any subsequent term, is equal to the term before. So if I'm looking for the second term, so this little n here would be a 2, then I would take the one before it, which would be 2 minus 1, which would be the first term, and I'm going to add 3 to each one. So I go plus 3, and that applies for every n greater than 1. So I've already had the n equal to 1 accounted for, so I want to make sure. All right, so let me show you how this works for this problem specifically. So if I were to find the second term, because I already have the first one, I would go A, my little n becomes a little 2, I subtract 1 from it, and I add 3. So 2 minus 1 is 1, so this is saying I take my first term and I add 3. Well, we can do that. That's 1 plus 3, which is 4. Then I find my third term. So that's my A value with my little n is going to become a 3. I'm going to subtract 1 from that little 3, and I'm going to add 3 to the whole thing. So when I'm here and I go 3 minus 1, that is 2. So I take my second term, which I found to be 4, and I add 3 to it, which gives us 7. So then the next one, A4, is going to say take A2 and add 3 to it to give us 10, and then add 3 to it to give us 13. So it is a way to kind of circulate back to the one before, so we can add 3 each time. All right, so let's look at a couple of examples. We're going to write a recursive formula. So let me give you two different sequences. Your first sequence is 1, 2, 6, 24, 120, 720, da da da. And you guys are going to have to start thinking like clever detectives. So we have a crime scene here, and we have to put together the pieces of what happened. So we're going to take, now the cool thing is, recursive formula, we can automatically identify the first term. The first term in this sequence is 1, and the first term in this sequence is 1. So we have half of our recursive formula done. Yay! All right, so the second half is the hard part. We have to figure out how to get from one term to the next. So we got to find the pattern. So I always look for adding first. 1 to 2 is 1, 2 to 6 is 4, 6 to 24 is 18, 16, no, 18. Yeah. If it was 26, it would have been 20. This is 96. So there's no adding pattern. So I know it's not adding. So let's look at multiplying. So this one is 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. 24 times 5 is 120. And I bet you 120 times 6 is 720. Well, I can tell you 12 times 6 is 72, and then put the 0 on. So what we're doing each time is we're taking the term that we're on, because if you look, I'm on, after the first one, I'm on term 2. So I multiply by 2. Term 3, I multiply by 3. Term 4, I multiply by 4. So we use the letter n to represent which term we're on. And we use a to the n minus 1 to represent each of the previous terms. So then we do let's do a little check just to make sure our brain's not crazy. So the second term is going to be 2. So we know the answer is going to be 2. In here, n is 2, so I put a 2 here. The term before is 1, and I get out 2. So let's check the third term, so this checks. Third term, I'm going to put, because I have a 3 here, I'm going to put a 3 in for my n. The term before was 2, and I'm going to get out 6. And that matches my sequence. Alright, that was like a little bit complex, but I wanted to show you ones that weren't going to be, oh yeah, I add 3 every time, or I take away 1 every time. This is as hard as it's going to get. You're going to have to start being clever, identifying the pattern, and if you get stuck, just let me know. Alright, so for B, our first term is 1, and if we look, we are not increasing by the same amount every time. Boo. But there is a strange kind of squared that happens. So if I took this number here, so 4, and I added 1 to it, I would get 5. If I added 5 and 9, I'd get 14. 14 is I get 30. There's a pattern. 4, 9, and 16 are all special numbers. They look special like we've dealt with them before. What is, can we say 4 is 2 squared? And 9 is 3 squared? And 16 is 4 squared? Nice. So would it be reasonable to say that I take the term before and I add the square of whatever term I'm on? So if I'm on the 3rd square, I square 3. If I'm on the 4th square, I square 4. And then let's do a check just to make sure. So I take the term before, and I'm on term 2, so then I go 2 squared. Did I get 5 for my second term? Yes. Let's check 3. I take the term before, and I add the n squared. 5 plus 9 is 14. So both of these check out. So we're going to do one example of an explicit formula. And then we're going to, so given the formula 0, 3, 8, 15, 24, dot, dot, dot on for forever, we want to find the 20th term. So before we do that, we have to find the pattern. So I'm going to swing from 0 to 3, our difference is 3. From 3 to 8, our difference is 5. From 8 to 15, it's 7. From 15 to 24, it's 9. And then guess what the next one will be? 3, 5, 7, 9. 11. So we want to write the explicit formula. So we're going to go A with a little n. We want to just plug in whichever term we're on. So if we're on the 15th term, I want to plug 15 in to my explicit formula and get out that term. I don't want to go the recursive route where I'm doing the same operation, and to get to the 20th term, I have to do 20 calculations. I want it just one and done. So what the pattern we have to look for, and since this isn't, it's consistently giving me odd consecutive integers, but that for me was very difficult to see the relationship. If I look at this in terms of squares, so if I were to just go compare it to a list of squares, do you guys see a better pattern between, here's the list of squares, here is our current list. How are they related? So it's 0, 3, 8, 15. Compare it to 1, 4, 9, 16, 25. So this is 1 squared, 2 squared, 3 squared, 16 squared, 25 squared. And then compare them. How are these two numbers related in each of the terms? So how are 0 and 1 related? How are 3 and 4 related? Yeah, they're one number apart. So when we want to find the term, we're going to square it and subtract 1. I looked at, because I know my squares, and from the couple problems before, it's alerted me to kind of track squares. I said, well, 0, 3, 8, 15, 24, that's pretty close to my squares. So I decided to write my squares down and see if I can't muscle out a relationship between them.
16 or 1 point?
16.
Okay.
So we found the pattern. It's that we square whichever term we're on and we minus 1. So now let's apply that to our 20th term. So if I want to find the 20th term in the sequence, all I'm going to do is put 20 in for n and subtract 1. So 20 times 20 is 400 and minus 1 is 399.